All right, good morning, everyone. Thank you for coming here today. We have a fabulous topic on sensors. My name is Fred Bisania. I work as a program manager on the sensors team. And what I wanted to do is tell you a little bit about ways that you can work with sensors and what you can gain. So the idea here is, what is it that ISVs, our software developers, can do to take advantage of sensory information to adapt themselves to the environment that they are in, and how they can differentiate their apps so that they can have a higher score, higher rating, higher downloads. Those are the kinds of things I'm going to spend some time on today. To achieve that, we'll talk about the following topics over here. I'll start first and foremost with sensors. What are the sensor capabilities that are available now in the new platform that's basically on sensors on Windows Phone as well as on Windows 8.1. From there, we'll go into what are the things you can do to optimize your app for sensors. Because there are a lot of things we can do to start up. Everyone believes that it's very easy to get access to a sensor, which is true. But how do you make it so that you optimize yourself from power, from efficiency, from a user perspective around sensors? I'll give you some tips around that. The third phase is, what do you do with the different types of hardware? Some have more advanced capabilities, some have optional sensors. So we'll give a few tips over there on how you need to optimize yourself for that. So with that, I want to go ahead and talk about sensors a little bit and give a little bit of an introduction to where we came from. The word sensors is used for a whole bunch of different types of devices. I hear about the touch sensor. I hear about the keyboard sensor. So what I want to do is I want to provide a little bit of a framing. For the talk today, these are the particular sensors that we're going to work on. And I want to take you back into a little bit of history. The topic of sensors started with Windows 8 and Windows Phone 8. And I want to show a little bit of a video that'll help give you an idea of the sensors, their capabilities, and from there I'll go into what's available on the modern platforms. All right, let me play this video.
With Windows 8, you can create apps that provide new and unique ways to interact with the user. This video provides you with a quick overview of the sensors available on Windows 8. Windows 8 supports a number of sensors. The accelerometer returns the measure of g-forces on the device with respect to the x, y, and z axes. The compass returns a heading with respect to north. The gyrometer returns the measure of angular velocity with respect to the x, y, and z axes. The inclinometer returns the pitch, roll, and yaw values that correspond to rotation angles around the x, y, and z axes. The light sensor provides you with the ambient light reading as a lux value. The orientation sensor is an advanced sensor that returns a rotation matrix and a quaternion that can be used to adjust the user's perspective in an app. A typical use for this is a racing game, where you need precise response to the movement of the device. And finally, the simple orientation sensor, which detects the current orientation of the specified device or its face-up or face-down status. Each of these sensors have similar APIs. They let you get a connection to the sensor if it exists, get a one-time reading of the current sensor value, get continuous updates of the current sensor value based on the requested report interval property, and get the minimum report interval supported by the device. The accelerometer also provides the shaken event to let you know if the device has been shaken. By incorporating these sensors into your apps, you can create engaging, interactive apps that are unique on the Windows 8 platform. Thanks for joining us for One Dev Minute.
So guys, I wanted to show that and start with what are the sensors that we support, and I'll let the voice get, okay, thank you. I wanted to show that video to show what are the sensors that we support back in 2012. We started on the project with both Windows 8 as well as with Windows Phone 8 at that point in time. And these are the basic sensors. Since then, we want to make it easier for the application developer. So we started working on a few things. First is we focused on making sure that the same apps can get access to the same types of sensors. So if you think of the raw sensors that we have over here, it's not only that we have access to these from both Windows Phone 8.1 as well as Windows 8.1, we actually have the same characteristics and the same capabilities. We go a step beyond to say that if you want to use a particular sensor, you can take that and use it in the same way across both of the platforms. The one thing that stands out differently is the short-range proximity sensor. That's primarily found on the phone. The perspective is when you put your phone to your ear, you want the screen to be dimmed out. We take that information and we also have it available to apps. So apps have the ability to go through and do something a little bit smarter and unique with it. So don't dim it out or pause music in addition to doing something. Let the app differentiate itself. The thing that I have at the bottom is the derived sensors. The derived sensors are done slightly differently between the two platforms, between Windows Phone 8.1 and Windows 8.1. But the result of the differences are not visible at the application layer. The three of them that are interesting that we spoke about are the simple orientation sensor, the device orientation, as well as the inclinometer and compass. If there are any questions on any of these sensors, I'd be happy to go into the details of why they're different. But primarily, we wanted to try two approaches of what if we took all the sensor information and did fusion in software on one platform, and on the other platform, we said, what if we allowed IHVs to go through and differentiate and try a few different algorithms of their own? And so far, both have had their advantages and disadvantages, but there's no clear winner. But I wanted to share that knowledge with you. So as we move forward, what are the key fundamental differences in Windows Phone 8.1 with respect to sensors? And I'll start with some of the basic things. The light sensor. Everyone thinks of this as a very basic form of sensor, but it's meant to achieve two very distinct things. Number one is it's meant to improve readability. Plain and simple, there are things that Windows will do with respect to the brightness control so that you can go through and read it in the different lighting conditions. But number two, and this is probably the more important thing, is it's meant to reduce eye strain. So when you're reading on a particular device for an extended duration of time, there are things that applications can do beyond what Windows does to reduce that eye strain. So I get the question quite often from time to time, can you give us those specifics? What are the things that applications should focus on? Because not too many applications do this today, and this is a great opportunity for yourselves to differentiate your app from somebody else's app. So what we did was we went and spoke to our research team and the readability team. We said, look, we're here at Build, we have an awesome opportunity to evangelize the light sensor, but what's the right way to do it? And they came back with two approaches. One is the what that needs to be done, and the second is where or when does it need to be done. So if you think of lighting conditions, we broke them out for simplicity's sake into these four conditions, which are outdoors, the indoor bright, indoor dim, and a dark room. It's best if an application can differentiate these four things and do certain things that are unique with it. But at the very least, the two extremes are critical. Imagine that you go outdoors and you cannot even see what's on your screen and nothing happened. You wouldn't even know how to adjust the brightness at that point in time yourself. So that's where Windows starts, and we give all apps the simple benefit of having the application's brightness changed. But we said, okay, readability team, what's the next thing that an app should generally do? And they came back with the following guidance. The first thing is maximize contrast. I understand that you wash out colors because of that, but it at least provides readability. The third thing, especially in the dim lighting conditions, is go through and inverse the reading layout. So if you had white on black, change it to black on white. The benefit of a dark or a black background is that's what the eye sees pretty much all around it in a dark room anyways. So by having the rest of the text be white and the background of the phone be dark or your app be dark, it's very easy and it reduces eye strain. The fourth one is adjust fonts. Now you often hear adjust fonts, but you have to be delicate when you adjust fonts. You cannot just increase the font size all of a sudden because not only does everything on the app, the screen real estate get jarred up because the font size changed, it can be very frustrating to the user. So a tip over here is don't do it from a very small font size to a very large font size. Follow two tips. Tip number one is when the user is doing something with an app, let's say I'm reading a page and I scroll across to the next page, take that as the opportunity to increase the font size just a little bit. So that's a second tip. Don't go all the way to the very extreme. Do it just a little bit at a time. By the time they go to about 3 or 4 keystrokes and go to the font size that they are reaching, they don't even know the font sizes have changed. And it works out quite well in most of those cases. The second thing is there are times when you go from an indoor dark to a very bright lighting condition. Have some heuristics there. When you identify that, don't take such a stepwise approach. There, you need to have a sudden jump up. in order to take advantage of it. So while these lighting conditions are important, be careful that there are some edge conditions also. One of the examples that I ran into is I was holding the phone or the tablet, I can't remember which one, and I was walking through a hallway. And the lights in the hallway were pointing straight down. And every few steps I would take with the device, all of a sudden the brightness would change, the font size would start to change. It was frustrating. So the tip I would say is be gradual when the lighting conditions are changing gradually. Take time and give a little bit of a buffer zone so that when sudden changes in light appear or your app gets a sudden spike, it doesn't react to it right away. Another good example that I ran into was I was reading on the tablet. I had a white screen behind me or a white wall behind me. I was watching TV at the same time. It was a dark room. All of a sudden, the changes that were appearing on the TV would bounce back from the wall behind me, impacting what I was doing with the app. All of a sudden, it would change white background, black background, frustrating. Simple fix. Wait for a certain duration of time of about 5 seconds. When those things were consistent, don't change it. Or if you see it constantly fluctuating, don't change it. They're in an environment right now where you shouldn't go about doing some of these things. So I wanted to share some of these tips so that you can build your apps more elegantly to adapt to the user's condition. But why is it important? It's important because we did some investigations that the average reader type application, less than 10% of them were using the light sensor. And the ones that were not only had higher ratings, we actually saw statements from the users in the store that they enjoyed reading on that particular app. But when we go about doing studies, because it's very easy to measure eye strain. There are muscles right under the eye. You can observe them over periods of time. And when the user doesn't have to squint when reading, it reduces eye strain. And that's what we saw, that apps that listened to the light sensor actually resulted in lower eye strain. The next one, this is also being projected in Windows Phone 8.1, is a simple orientation sensor. A lot of applications want to take advantage of knowing whether they're just face up or face down and do a simple gesture based on it. You don't have to listen to the accelerometer and calculate this all by yourself every single time. And note that the accelerometers on different devices may be oriented slightly differently. So all you need to do is subscribe to the sensor. And now, let's say you're listening to music, somebody walks into the room. You don't have to go through and hit the volume button down. You don't have to unlock it and pause your app. Your app could be smart enough listening to the face down event, and as soon as you flip the phone over, it goes into a silent mode. Simple little tricks, but they really help differentiate applications quite a bit. The third one, and this one is very near and dear to my heart. It's around lock screen apps. With Windows Phone 8, we did enable lock screen apps, but we did not provide functionality to the sensor's information. With Windows Phone 8.1, you not only have access to lock screen, they have access to all the sensors that I was talking about, and you can do simple things like logging data. If that's the last app, leave it running. There are all sorts of applications that monitor sleep conditions, etc., so they can keep getting this information even in lock screen. But lock screen isn't enough. We all know that multitasking is critical. That's what people want. That's what people love. I keep, on an average day, going through at least 20 different apps on my phone. But there are certain apps that I want them to have access to the data from the sensors when they're in the background. So the fourth one is we do enable background access to the sensors now from your app. So when your app is now swapped out, you can go through and get access to all the sensors that were running. And in fact, I'll go through and do a little bit of a demo also of how easy it is to build that into software. But there are certain caveats. So in terms of the requirements and the tips that I would provide, while it is available to native apps as well as to Silverlight apps, you have to use something called a device use trigger. The device use trigger is used to tell the application or the background task whenever there's new data that's coming about. But the number of such triggers that are available are constrained, and they would vary based on the device that you have. So a more economical device with a lower RAM footprint would probably only have one device use trigger that you can go through and use across multiple apps, versus some of the higher-end devices would have more. The second thing is the device triggers and the background tasks do consume power. They may be running on the application processor themselves. So when the phone reaches a low power number, your background task may be terminated or may be paused at that point in time. So the application should be smart enough to provide some contextual information to the user, or the user could go through and even adjust, if they want to, at what battery level they want some of these things to kick in. So let me jump in and show a little bit of code of how simple it really is to take advantage of background stuff. I will go and start my monitor. All right, so the sample that I have over here is called the background sensor sample. This is there in the sensors gallery. And let me start it off with actually showing what it looks like. That'll actually make it easier to walk through the code then. So the perspective of this sample is to show you how do you get access to sensors data, even when the application goes into the background. To keep it as a sample and to keep it very simple, all that we do is we keep a counter running for the number of sensor samples that are being collected. You can, of course, augment this to do something smarter. You can go through, rather than just counting the number of sensor samples, you can do some algorithms on those samples also. But let me show you the code. So go through on the phone, enable it. You'll see data that will start coming through in just a few seconds over here. In this particular sample, we go through and set a report interval of about 16 milliseconds. So you're getting about anywhere between 60 and 70 samples coming through every second over here. If I hit the back button in the past, what would have happened is I would have gone back to my start screen, and very quickly it would have lost access to all the sensory information. All right, so instead of that, let's, stay here. So I go over here, click it again. The original number was about 700. Right now, what you're looking at is about 2,300 samples. So a simple way to show that it is actually running, you can go through, disable it, enable it, and it'll show you, boom, it's still starting from scratch again. How did we get to this in code? Let me close this down and show you. So as I said, there are a few basic things that you have to remember. You have to use the device use trigger in order to get access to this in the background. So the first thing is, in your app manifest, you have to make sure that you go into the capabilities, the declaration section, and select the device use trigger. This is critical so that you can go through and schedule your background task. In this particular sample, we have two projects. One is the background sensors project, and the second one is the background task itself. So I'll walk through the background task first so you understand what it's doing. So we have a sensors background task. Go through and initialize it, get access to the sensor through the getDefault function, and go through and set it out to 0. The other thing we're setting is the report interval. So remember, there are two characteristics that are available for all sensors. One is the report interval, which is how often do you want the sensor to send you data, and you can control that to save power. And on the Windows 8.1 side, there's also something called change sensitivity, which is a magnitude function that unless the data changes by this magnitude, don't send it to me, because I really don't care about the little noise that comes from all sensors. So in the sample here, we're going through and setting it to 16. And pretty much that's about it. And we're going through and setting up the cancellation routines for when it gets through. Here's the on cancel. And then the only thing other than that that's interesting is what do you do on reading change? In this particular sample, we've just gone through and incremented a sample count. The reason for the sample being simple is because we just want to show it as a demo. But this is the area of code where you could go through and add some of your more complex algorithms to do something smarter with it. In terms of the actual application, well, most of this is sample code, so I don't want to show anything too specific over here, except how you go through and set up the, let's see, where can I find it? Oh, background task. Here we go. This is the most interesting function in my opinion. You go through and say, start the background task, initialize it. Remember, there's one thing to watch out for. The background task and the application itself are different processes. Especially while developing, there are several times I've made mistakes where my application just crashes, but the background task is still left alive at that point in time. So when you're starting up your app, make sure you identify the background task and go and unregister it if it's running previously, and restart it if you need to, or at least bind to it. The other thing I want to bring out is when you do register your background task, remember that there are three things that can come about. Your background task may actually start just fine, in which particular case it's allowed and you go through and just say it started. But there are also other conditions like the low battery condition and the denied by the system condition that you have to watch out for. The low battery condition is when the user's battery is less than like about 20%. And that's changeable by the user also. But the perspective is that the user wants to maximize the amount of time they can still use the phone. The second one, denied by the system, is because there's a maximum cap, at least in the current implementation, of how many background tasks can be using the device use trigger. So if there are about 15 apps that are doing it, well, not all 15 of them are going to be able to run their background tasks simultaneously. Because these are initiated by the user when the user starts their phone, we haven't encountered too many issues where there are too many conflicts of this. But this is an area that we're continuing to refine moving forward. Other than that, there is very little. So if I go through and emulate it again, I want to show you one more thing in the emulation. Come on. OK, it's being deployed. So when we start it up, as I was saying, you only get the sensors count over here. What you can do in the emulator also is if you want to send specific sensors data, you can go through and select the particular sensor that you want. So in the emulator, you do have the accelerometer as an example. And you can try scenarios where you actually go through and say, OK, I want to send different accelerometer data. And the data which you see at the bottom right here is the actual data that's being injected into the application. And as an example, I can go through and try doing something like I spin the app or the phone around, and boom, it actually goes through and emulates it over here. So it's quite rich if you want to send different application different sensor data, including recorded data, which you can just play back from here. So if there's a scenario where you're doing a step counting algorithm, and you recorded the actual accelerometers where the user was running into problems, you can go and feed this into the emulator and debug the issue right there. All right, so let me just switch over back. So in terms of the code, we actually walked through the background sensors one. Just as a key takeaway, the stuff that we paid attention to over here was number one, make sure that you declare it in the app manifest. If you don't, it'll be hard to debug why it isn't working, and I've faced this problem myself, so I want to share that knowledge with you. The second one is, remember, it's a different process. So even though your application, when you're developing it, may run into issues and be terminated, the background task still continues to run. And the last one is pay attention to battery. A lot of people think of sensors as, hey, I just open it up. It doesn't consume much data when the phone is running, so it's OK. Well, it does consume data. It does use power. And make some smart decisions with at least the report interval. So if you're trying to figure out, count the number of steps when a person is walking, and you're not doing this on a low-power core, and I'll show that to you, how to do that in a little bit also. Well, change your report interval. When there's no activity or no major activity, keep it low. When you see activity starting it up, go and ratchet up the report interval. And almost instantaneously, you'll start getting data much faster. All right. So we talked about some of the new things that are there in Windows Phone 8.1. Let me go about and talk about 3 specific tips. When anyone is starting to build an application that leverages sensors, as you saw with the code, it's really easy to get access to that data. People often start in the emulator just to try things out. But when you start going to the actual devices, different devices have different permutations of the sensors, different orientations of the sensors. So I wanted to walk you through what are some of the hurdles that you may run into as you're starting to build the app. So the first one is to understand the difference between the display and the device orientation. The display orientation is what you're actually seeing that's being painted on the screen. The device orientation is according to the sensors on the device, how is it being oriented? Because the sensors may be mounted differently on different systems. When we started with Windows 8, we actually had most of the systems were landscape-based systems. The phone was a portrait-based system. And they were oriented in exactly the same way. When we went into Windows 8.1, we started seeing systems that were tablets coming about in portrait form factor. But to preserve application compatibility with the apps that were already there, the OEM manufacturers went through and mounted the sensors in a different orientation, as you can see over here. So what's happened now is a little bit of confusion that's come into the ecosystem. We have a white paper. I've got the link at the bottom on what you need to do as an application developer. So if you're building accelerometers or gyroscopes, what is the mapping system or the coordinate system you should be using for reference when you have a different display orientation? It's really not that hard, and we are working on having an API that says, tell us which reference frame you want us to use, and we'll do the matrix computation behind the screens for you. The next one, as I said, was conserve power. I keep repeating this. This is near and dear to me. Our customers care about this. A poorly written app that doesn't conserve power almost always gets identified by the user very quickly, and those are not the kinds of comments you want to see in the store. So the first thing is listen to the sensors that make sense. And the reason why I state that is we started to analyze a number of sensors, including ones from Microsoft, and we noticed apps that were going through and saying, well, I'm going to need at least the accelerometer, but let me check if the other sensors are there. They would check, and they would leave them on without dereferencing the handle or closing it out. The problem with that is by holding a handle to the device, the sensor is on and continuously sending data to you, even if it's small. Now, I understand the background, the screen may be consuming a lot more power than something like a sensor, but if you're running it in the background, without knowing, you'll be bleeding a lot of power. Adjust the report interval, and as I was saying, background tasks may be suspended. So if you notice that condition, make sure there's synchronization between your background task and your application so that you're aware when this condition does occur for you. The third one is, how do you make your application work well with sensors in the real world? We all start with sensors in the emulator. As soon as you move from the emulator to the real device, you get hit by a few things. Number one is sensors have noise. When you expect that the phone isn't moving, you're still going to keep getting a lot of sensory data from the phone in the form of a little bit of noise, and make sure that you understand what you want to do, what your thresholds are appropriately. Secondly, is that amount of noise does vary between devices, so try on a few different device configurations. In the case of a magnetometer, calibration is critical. We actually provide you with a hint that we believe the quality of data coming through from the magnetometer is either high or low, and we allow the application to paint its appropriate UI. We have recommendations. We have it in the sample of the figure 8 UI that you can use. But if you want to do something that's richer in the app or play a game or something of that sort, you have the flexibility to do so. But calibration is critical, especially for the magnetometer or the compass, but also for certain other things. If you had a level app and you wanted to show the exact angle of declination, you would need a calibration function just to make sure you weren't off by about a degree or something. The second one is availability. When we started with Windows, we actually had certain requirements for tablets. We said that anything that was in a tablet form factor, per the logo requirements, had to contain things like an accelerometer, a compass, etc. Now, why? We wanted to keep it as a consistent interface for the software developer, so you didn't have to worry about it too much. The problem is there are new hardware configurations coming to market, different price points that are coming to market. So the sensors that you had seen in the past may not continue to appear on all the systems as you move forward. So check for it. If you're not getting a gyroscope, you may be able to still do something with an accelerometer. If you're not getting device orientation because you don't have full 9-axis fusion, you can still go to just a gyroscope and figure out when angular movement is taking place. The last one is, because of the configuration changes on a few specific phones, try and follow the guidance around device orientation so you don't get bit by it as you're walking through. The resources and environment, start testing your apps in the emulator first. Start these different scenarios which trip up a lot of applications. But the real environment makes a huge difference. I gave you the example of lighting. I was sitting there, white background, reflection caused all sorts of things in the application. Those are the kinds of things that only come about once you either test or when you hear from your other fellow friends who are doing some similar things. So I wanted to share some of those tips with you. And last is, make sure that you have the relationship between the app and the background task well maintained. Let's move forward to the third section, which is basically, how do you go through and take advantage of the hardware configurations that are there in your applications? So as I mentioned, there are different types of hardware configurations coming about. Some of the newer phones that you'll start to see coming into the market will take advantage of facilities that are there on the Qualcomm Snapdragon's sensor core. One of the biggest things that's there is it's a separate core that is there on the SOC. And the purpose of that core is primarily to take data from sensors and not bother the rest of the cores while that situation is taking place. So in an example, and you probably saw some of these things being used as part of the sensors demo talk that was there from Nokia yesterday, by having the phone off, you're trying to count the number of footsteps. You don't want the rest of the application core being consumed with too many other things. You want the sensor core to actually count the steps and then share it up based on certain intervals or events which do happen. We have that facility that's wired up. It comes through the drivers and the infrastructure from Qualcomm. It gets augmented through the APIs that are provided by Nokia in this particular case, where you can do things above and beyond some of the simplistic APIs that are already there for all application developers. The second thing, just as an FYI, is we changed the driver model a little bit. We took advantage of user mode driver framework, that's UMDF 2.0. And the reason we did that was we found a few situations where the manufacturer of the sensor or the driver developer for the sensor tested it in most of the configurations they thought were the general configurations. However, application developers sometimes push those drivers to the limit. And we do not want to see the average user having an experience where they tried setting something magical and the whole phone crashed. By moving across to UMDF 2.0, the experience that the user will see is that the driver will still go down. However, it'll come back up and data will start coming through the stack. So as long as the application is able to handle the hiccup and reset its sensors at that point in time, it'll be almost transparent. So the advantage is at least the user doesn't have that kind of a devastating effect. The second part I want to call out is we are on a path to make sure that UMDF sensor drivers, UMDF 2.0 sensor drivers from phone will also be ported across to a future version of Windows. So an IHV who's writing that driver needs to write it once between both the platforms and not two different interface sets that exist. Of course, we will preserve the KMDF driver model. There will be a number of phones that just get upgraded that are in the wild today. And we want to make sure that those sensors continue to function when you move across to Windows Phone 8.1. The optional sensors. We mentioned this a little bit. As you continue to see different hardware form factors over the next several years, you will see a new breed of sensors coming about. Some of the common ones, like the accelerometer, the light sensor, will continue to stay there. They're used for a lot of the things like the sensor fusion core, which I've shown on the right. But a lot of other sensors will be on certain specific platforms, and a lot of other sensors will just not exist across all platforms. So make sure that your applications take advantage of these conditions. And the ways you can do it is check for the presence of some of these sensors, and if they're not available, you may be able to write some of your own algorithms with a specific sensor that is there. If not, take some other ways of doing it. See if you can get other forms of input modality coming through. So instead of using just the sensors to play the game, you may be able to show touch-based game control on certain phones. So I just want to make sure that people are aware of some of these configurations. So with that, I want to bring us to a little bit of the end and open it up to question and answers. In terms of the key takeaways, remember that Windows Phone and Windows Phone 8.1 have provided a lot of new innovative sensors that are coming about through the sensors core, through Nokia's SDK. Take advantage of some of those sensor capabilities. Be consistent and cognizant of what the user is intending to do. We can go very smart with sensors, but remember, it's just data that you're getting from the sensors. So use that data wisely. In certain conditions, like low battery conditions, you may not even get some of that data consistently, so be aware of that. And lastly, by following some of these practices, you can make sure that your applications run uniformly or universally across both Windows 8 and Windows 8.1. So what I've done is I've thrown some of these references in here. All the information that I talked about is covered. Don't worry about the links. It is being recorded, so you can see it. I would also recommend after you view this talk, you do take advantage of the Nokia talk that was also provided yesterday. It's recorded, so you can go see that and how it builds on this. And if you don't worry about the links, you can always type in these titles into Microsoft.com, and you'll find that. And with that, I would like to end the presentation, but I'm going to ask you for something over here, please. I care a lot about feedback, so please do use this link over here and kindly give feedback in two areas. One is for my own personal growth, of course, but secondarily is we would like to know how our partners are using the Sensors platform today. What are the types of apps that they're using it for? And what are some of the gaps that they have run into using the platform. So if there's anything that you can write in and fill in the open feedback section, please tell us what are the kinds of sensors you use and what are some of the gaps that you've run into that you'd like us to work on moving forward. All right, so with that, thank you very much for your time today. I appreciate your patience over here with us, and I'll open it up to any question and answers, and I'll end the presentation right here. Thank you.
First thing I've noticed is that you've added in the inclinometer class into Windows Phone, where it used to be the motion class.
Correct.
So it's very similar to the old motion class then. Okay. Are you going to be adding into the classes the ability to add in filters? In other words, to take samples over a period of time and give us a more stable value of the sensors rather than the jittery one-shot?
I know exactly what you're asking with respect to that question. We actually had a video that we showed, I think it was at Build last year, where there are certain kinds of filters that you can put, like a low-pass filter, and provide that kind of data. There's always a trade-off that happens when you take that kind of a filter that you apply. The example we were showing was a car racing wheel. And we showed it when you had no data and the racing wheel was just shaking ever so slightly. We put a low-pass filter, but what it introduced was a lag. So as soon as you would turn it, there was that slight delta that was there between when you'd move it and when the wheel would actually get all that data being processed through. What we reached was a simple conclusion that there are a number of different filters that are available in the open community today that you can take advantage of in your apps. By having only a few specific filters being available in the operating system, we didn't think the experience would be as ideal, and we really left it up to the application developers. Now, with that said, we are open to trying different things. If you feel that having certain filters would be available, I would encourage you to put that in the feedback, and I'll take it back to my team to try it out.
It'd be nice to be able to extend the class to have the filters built in so we can just use them, our own custom ones. The other thing, too, is as you're flipping back and forth the phone from one position to another, you need a little bit of heuristic around the, 15 degree up, start switching, 15 degree down, you start switching. You don't have that. It's still a little jittery at that point.
Is this for the screen orientation?
Yeah.
I tend to agree with you. With every operating system, we have continuously tried to make the algorithms better and better. So in the example of the screen orientation, it's actually, in my opinion, much better than what it used to be in the past, even for tablets. In the case of the light sensor, while we've got an algorithm, our partners at Nokia have even gone through and added additional hooks in order to improve the brightness conditions even further on their phones. So OEMs may be able to enhance the experience even further over there.
Have you, on that same thought, as you're going down, you have flat, upside down. Do you have portrait flat and landscape flat?
No, we don't. We only actually have those 4 quadrants of 0, 90, 180, and it's very hard to figure out across all devices whether you're flat and in portrait and then move it across to landscape or vice versa.
I know.
And no way. So today, the simple orientation sensor only gives you the 4 degrees, 0, 90, 180, all that stuff, and then it gives you face up, face down. It doesn't give you portrait up, portrait down.
Okay, thank you.
Sure. Yes, please.
Yeah, the compass you got built into it is using magnetic north. And is there a way to create it so it can actually find geographic north?
So the Windows API set actually provides you with true north as well as magnetic north at the application layer.
Is it pulling from a GPS data then?
So the way it does it is it relies on the driver manufacturer to provide that layer data with it. It can either do it via GPS, it could do it by having an approximate location based on a Wi-Fi lookup and give you, well, pretty much approximation of how much the delta or the declination is. So in San Francisco, I think it's about 15 degrees over here.
To answer his question, by the way, we actually use the compass to actually do orientation.
Mm-hmm.
So when you changed it on the table, it changed it from portrait to landscape.
Yes.
And so we utilized the compass in order to do that.
Yes, that is one way of doing it. The problem is compasses are not available across all phones or across all tablets, but when available, yes, we can take advantage of it. Yes, please.
Yeah, so when I sign up for the events in the background on a sensor, what are the restrictions that I have on calling out to stuff on the phone or even the web?
What are the restrictions to calling out on the phone?
Yeah, so are there any restrictions when I run in the background in terms of the number of CPU cycles that I can take? And
Absolutely.
Okay, so
there's a number of constraints that come in. They're not only for sensors, but they're across the board. So there's a limited amount of time that you can spend running in the background. in terms of
Okay,
actual man
so
clocks.
it's the same quotas that you have just for running in the background. There's no difference if you
Correct.
just sign up for the sensors or just run a background task.
The only difference over there is when you are using the device use trigger, there is a constraint of how many applications can have a background task registered to run in the background.
Okay, thanks.
Sure thing. Yes, please.
Yeah, I understand that the connectivity for the sensor right now it's supported on both USB and I2C. So you have a hit over I2C and hit over USB. Do you have any plans to support SPI or any other bus?
We've always left that platform open. So what we have today is we have, at least on the Windows side, we have a class driver for sensors that is abstracted over a layer called the HID layer, HID. HID has a certain number of fixed mini ports that it understands how to work on. I2C, USB, Bluetooth, Bluetooth LE are some examples of that. We have been open to adding SPI as a definition of it. We're eager to work with people in the industry who are interested in using it. So if you are, I'll give you my business card. We can, of course, connect up offline and go into some more details. It's possible to go through and do so. With that said, it is also possible for a device manufacturer today to write a driver that goes natively over SPI and goes straight into the sensor's infrastructure on the Windows tablet. So that's possible to do.
So without having the HID?
Without going through HID, yes. You can go straight using the sensor's DDI layer, write a driver, and talk natively to SPI. There's also a platform for SPI that is there on both Windows Phone as well as on Windows that is through the SPB interface. So you can go through and use a consistent API set on both of them, write a driver, and when we even get the sensors DDI set unified, which we're marching towards, it'll be a singular driver.
Okay. So in terms of GPS, do you have plans to support HID over GPS?
I cannot comment to future ones at this point in time, but on the current platforms, no, it's not available.
Okay. All right. Thank you.
Sure thing. All right. Thank you very much for your time. I really appreciate it.